So question number 1 is looking at a computer company which received a rush order for as many home computers as could be shipped during a 6-week period. This company has the following daily shipments. Now, this kind of data you're seeing here is called ungrouped data. So when you're given ungrouped data, you need to find a suitable number of classes. By suitable number of classes is a formula that we use to identify how many we have in here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So 6 times 7 gives us what? 42. So this is our sample size n. When we go to our notes or our textbook, you discover that whenever you're given a sample size to find the number of classes, we have a formula that we use. And this formula simply asserts as follows, that you use n should be less or equal to 2 to the power k. What does this mean? This simply means that for us to know the number of classes to use, what number can we power 2 to get a number that is greater or equal to n? So for this example here, we had 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Our n was what? 5 times 6 was what? 30. So what number can I power 2 to get a number that first exceeds 30? Now, I want to dominate my time there just so that you understand, because this is important. You should draw a mini table just up to 7. 0, 1, 2, 3, 4, 5, 6, and 7. All right? Then 2, 2. So our answer, let's find our answer. This is just a table that will help you even in the exam. So 2 to the power 0 is 1. 2 to the power 1 is 2. All right? What is 2 to the power 2? 4. 2 to the power is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 is 8. 2 to the power 4 is what? 16. 2 to the power 5 is what? Let's multiply 16 times 2, 32. 2 to the power 6, let's multiply 32 times 2, which is 64. 2 to the power 7, let's multiply 64 times 2, which is what? 128. Tulipamo. Number. These ones are 30. What can I power 2 to get a number that first exceeds 30? So when we go here, 2 to the power 5 is what? 32. So my k therefore will be what? These are the k's. We pick 5 there. That is the reason why in this text, this should be your Bible. They chose 5 there. 5 is the number of classes. 5 divided into 14 is 2.8, which is approximately 3. Wrong one. So when we go to our assignment here, 6 times 7 is 42. So we need to identify the number of classes. Which number are we going to power to first exceed this 42? So we go here. Let's identify. It can be 5 because this doesn't exceed what? 42. 6, yes, because 42 is somewhere below there. So our k we're going to get is what? Our k is what? Our 6. So that's why we use 6 here. So when we go to our assignment, I just want to refer so that you see what was being done. We use this 6 here, not because we just thought on our own. He was very intelligent, this man, by saying a suitable number of classes. So you identify the highest number. Our highest number in this distribution is 87. And our smallest number in this distribution was what? 22. So we divide 87 minus 22 divided by 6. We get 10.8, which is approximately 11. Into a number by 22. All right. Whenever you're doing inclusive numbers, just do a minus 1, for instance, if you want. 22 plus 2 to be 10. So 22 plus 10, 83, 44, 45, 46, 66, 67. So this is a class width of 11. I don't know whether you get what I'm meaning. From here to there, you just count from 22 itself up to 32. Square, how many figures are there? 11. So 22, 23, 24, 25, 26, up to 32, we have 11 as our class width. Then we go to 33, 34, 35, up to, so we have our 43 here, so we have 11. Then we have from 44 up to 54. So you just start picking in there. I'm not going to take the whole time to pinpoint that because I've verified this twice. So we have 4 of the frequency between 22 and 32. We have 4 between 33 and 43. We have 9 between 44 and we have up to this. So these are our frequencies.
Hi, Colin.
Yes, sir.
Sorry. So for me, what I did is I used a number of classes. I used 7. So when I did the calculation, I did 87 minus 2, gave me 65.
Before you go there, listen, I've explained how to get the number of classes. The number of classes, we are past that. You can't use 7. You use 6 because there's a formula which you use to the power k must be greater or equal to what?
Okay.
N. So already that is not correct. Any other questions?
Okay.
So Pali class with the classes, I've emphasized where it's coming from. This is a book is using, all right? Let's not deviate from what is not using. So this is very intelligently asking the suitable number of classes. We don't guess that, we calculate it. So if you haven't submitted it, please revisit your calculations. Then this is straightforward. When you total up, get 42. Of course, books differ. All right, I'm not saying this could be other books may find it differently, but I'm using his book. And then after we get the total, to get the relative frequency will be 4 over 42, we get that. 4 over 42, we get that. 9 over 42, we get that. 14 over 42, we get that. 6 over 42, we get that. 6 over, so this is how we get the relative frequencies. So here we're being asked to come up with what? The daily figures into the distributions having the suitable number of classes. So suitable number of classes that, the frequency is that one there. Okay. So group these into shipments into frequency distribution. The frequency distribution, and if you want, you can even add the CF. You see the 4 there, then we have 8 there, 17. We add 17 to that one, what do we get? 17 plus 14, that's 11. 31, 31, 31 plus that one, we have what? 87, and we have 42, which tallies. So this was done differently by different people, okay? So you can show your others use tallies as well. So the key thing was on the 6th, according to me. All right, so I can go to the next question, unless there are any questions. Now, stem and leaf diagram. Yes, there's a question there. if I go to the left diagram. Yeah.
College,
Mm-hmm.
for the frequency distribution, is it mandatory to show maybe the class midpoint on the table?
No, the
Or
frequency,
like what's
the frequency distribution only has class width, the frequency, and the yeah, just is stable. It's what makes it what we call the frequency distribution table. Sharp.
okay?
All right. Any other questions? Papata, this is the easiest topic, yet the most dangerous because it's bulky. All right. So to allow Hulishan, stem and leaf diagram. Like usual, I want to bring you with the basics. Then I take you through our assignment. I'll also quote you from our Bible. All right. So I'm going to add questions like 0, 1, 0, 2, 11, 12, 13, 13, 20, 23, 81, 33, 34, 44. I'm just using small figures so that we understand big figures. Sorry. I'll have to be elaborate so that even the BIDs understand what is happening. So tuwapata stem huku and tuwapata leave. By the way, BID means brought in dead, those that are really, really behind. So the numbers that we have here, we have numbers that start with a 0, numbers that start with a 1, numbers that start with a 2, 3, and a 4. As you join my classes, please ensure you do what? You mute yourself so that we don't disturb the class. So numbers that start with a 0, we have 0, 1. So the stem, we can't write another 0. So 0, 1 there. We have 0, 2 there. Then on the ones, we have 1, 1. We have 1, 2. We have 1, 3. And another 13 there. And the 2s, we have 2, 0. We have 2, 3. We're done. On the 3s, we have 3, 1. We have 3, 3. We have 3, 4. On the 4s here, we have what? We have 4, 4. All together on how we draw this. If we had
Yes, we are.
a 70 or 72, so we're going to write 5 there, 6 there, and 7 there. Okay, we follow this order, but after the 5 and 6, we don't put anything. Where there is 7, we'll put 7 too. That is how the tricky part is there. Don't just swap here and put a 7 2 there. I'll quote from your Bible again. So have you heard that? Have you heard what I've said? Are we together so far? So I'm going to go to your textbook.
Yes.
We have a certain example here. All right, so at this particular one, I'm just interested in you understanding the concept firstly. I've already explained that if you have numbers 11 up to 56, these ones, they had 1s, they had 20s, they had 30s, they had 40s, and they had 50s. So everything was filled up the way I've done it. Now, suppose we had missing figures. For instance, here, we have 8, 9, okay, 20s. We don't have 10s here, but we have 0s, we have 20s, we have 30s, we have 40s. So what do we do in that case? So zeros are here, 0, 9, 9. So even though there is no data point of the stem. It should be included in the stem and leaf diagram. I've seen some of you, because there was no number there, you were leaving it out. Y upper is 0, Y upper is 2, then because there was no 10. So the lecturer is very intelligent. He knows an assignment. So in this case here, parallel partition will go here. Zeros, there's 0, 8. And this one, people thought it was a mistake because it was so much an outlier. That man is very intelligent, so zeros are there. I'm 10 Stapali, but put a 10. I'm 20 Stapali, you put 20. 30s, there's nothing, you put 30s. 40s, there's nothing, you put 10. But 50s, they are there. 60s are there. 70s are there. 80s are there. And 90s are there. So this is where we can come up with this diagram. My key thing is, I want to leave out this part there. Most of you were leaving out that part. Leah, I think that's why you were getting confused. Are you clear now?
Yes, Collins, but check on the 50s if that's the correct, those are the correct numbers.
On the 50s, yeah, I think I made a mistake. On the 50s, there was one figure. So 50s, 56, 56. All right. So on the 50s, we have 54. So that's 54 here. Then we go to 50. I think I mentioned that in class. Thanks for reminding me. 56. All right. So this is 56. Yeah. 54 and 56. Yeah. I think that's it. Is that your observation you made, eh?
Yes.
Thank you. I'm glad you're going through, but the rest are okay, huh? So it's a 56.
Yes, the rest are okay.
Thank you so much. So Ngamamonoku, this data is skewed to the left. Was kuli capital. It's skewed to the what? To the left. You can see the shape of the diagram. It shows you that. Okay, it's skewed to the left in short. I can tell from there. So the question here was draw a stem and leaf diagram, describe the shape of the data set. Are there any outliers? Now, outliers can be identified by calculating the quartiles. All right, so you rearrange this data in ascending order. So starting from the smallest to the biggest. I don't know where it's supposed to be 6. All right, so how do we find the lower quartile? The lower quartile is simply a quarter of n. Okay, so our n in this case is what? What was our n? How many data sets are here? 20. Now the rule is this here. When you find a decimal number, for instance, 4 point anything, whether it is 4.1 or 4.9, you round up. If you find just a 4, a whole number, you add it with the next number, divided by 2. You find the average. So what is a quarter of 20? A quarter of 20. So according to him, of course, at undergraduate, we use n+1. So here, this new formula, he didn't use this in your class. So let's use what he was using in class. So you use a quarter of n. So our n is what? 20. So a quarter of n, half of n, and what? 3/4 of n. So I think he got to your attention last year. And he says he wants you to follow precisely what he's teaching. So some of the answers may be correct, but because of what he's prescribed, I'd rather let's follow what he wants. So we're using this formula. So a quarter of n is what? 5. So you count number 5. Remember, I said if it's a whole number, you get that whole number and the next number divided by 2. All right. So let's count. So a quarter of n, or a quarter of 20 is what? 5. So are we picking 5, or we're picking 5 and the 60th number? What are we doing?
We're picking 5.
No. What did I say? Number one, if I said, if your number is a continuous number, what do I mean by the continuous number? If that number has a decimal point, for instance, 0.5, you round it up, it becomes 3. If you get 5.25, you round it up, you get what? 6. Are we together? If the number is discrete, by discrete I mean what? A whole number. You average with the next one. For instance, 5. 5 means what? A 5th number plus the 60th number, you divide by 2. If I get 10 as a whole number, what does that mean? 10th number plus what? 11th number divided by what? Divided by 2. Are we together? So a quarter of n, our n in this case is what? The 5th number. So we're going to pick the 5th number and the 60th number. So 1, 2, 3, 4, 5, and 6. Okay. So the 5th number and the 60th number. So this is 62 plus 63 divided by 2. This is 62.5. This was correct. Then the upper quarter is 3/4 of n. 3/4 of n is a 12th number. Can somebody tell me what are we going to do with the 12th number? Quickly, in the interest of time, since it's a 12 is a whole number, we pick the 12th and the 13th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. 12 and 13. So 78. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Is that 3/4 of n? Are we together? 3/4 of n is what? It's 15. Is it? What is 3/4 of n? 3/4 of 20. 0.75 of 20. 3/4 times 20.
15. 15.
So what are we picking? The 15th and the 16th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. All right. So we're picking what? 83 and 86. So 83 and 86, we divide by 2. So that's how we got this 84.5. So this 84.5 is called the Q what? 3. This 81 is 62.5 is called the Q what? Q1. All right. So to identify the outlier, remember what we do. If we're doing a Box-Whisker plot, outlier is simply found as follows. You find the minimum value of x or the maximum value of x, and you put the interquartile range here, and you multiply 1.5 times the interquartile range here, and here the Q1, Q2, and Q3. So in this case, our lowest value of x, according to this value, was what? 8 and 93. These are the lowest values of x. 8 and 93. Our Q1 we just found as what? 62.5. And here we're at 84.5. 62.5. 84.5. When you subtract these two, what do we get? When you subtract these two, we get 22. So this 22 you multiply times 1.5, it's a standard 1.5. What is 1.5 times 22? What do we get? 1.5, we get 33. So this 33 is called the correction term. You add it here and you subtract it there. So when you add 33 to 84.5, when you add 33 to 84.5, you get 117.5. So you put 117.5 somewhere here. This simply shows you that this is our extreme value on the right. So 93 is not an outlier, it's inside. Then you subtract from this 62.5 minus 33. 62.5 minus 33, we get 29.5. 29.5, somewhere here. Any questions at this point?
So yeah,
So can you tell me which one is outlier in this case? So since this is the extreme value, it's like we bring a rule here, or a ruler as others call it. Any figures outside this ruler is called an outlier. So when you put at this extreme value and at this extreme value, the only number that is outside is what? 8. And the 3 is inside. So 8 is called an outlier. So what is our outlier? Our outlier is 8. So most of you, I think you got this correct from your assignments that I was assessing. So this is our interval. So 8 is the outlier. Can we proceed? Are there any questions at this point? Leah, are we together?
Yes, Collins, we're together.
Very clear.
All right, so I can go to part C, where we're looking at what? The mean, arithmetic mean. So N, the number of defective components and the number of boxes. So now the question is asking us from the information here, calculate the arithmetic mean of the component of the whole production line. So now here the key thing is you're going to multiply this times that, 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 and you add up, you sum them up. People didn't have a problem with that. The problem is over what? Over n, which one was your n? So this is how I summarize the data here. I called X the number of defective components, which then the frequency, I called the number of boxes here. So I totaled up, multiply these two, the total was 2,000, but the number of boxes here came to 1,000. So I divided by 2,000 divided by 1,000, number of boxes, which gave me our 2 here as our mean. So is that clear? Most of you got this, but again, I know you're not asking me questions that ask you what would be wrong with adding this and totaling up there. It's a question for another day, for another class. All right. So we go to question number 2. If question number 1 is clear, I proceed to question 2. Are we moving at the same page? So here we are looking at probability. So to start with, probability is what you started with, is what we call contingent probability and Bayes theorem. Okay, so we're told that according to the store's historical record, 65% of its digital camera customers male. 18% of its digital camera customers purchased a warranty, and 10% of its digital camera customers are female and purchased the extended warranty. Then we're being asked in this regard to determine the probability that a male digital camera will purchase a warranty, an extended warranty. So this question, we can come up with a key. So what are we given here? We can call males as M, females or women as W. Extended warranty, we can use letter E. So we are told that in its history, 65 of these cameras are male. So male is what? 0.65. So these are 2 mutually exclusive events. So it means that women should be what? The remainder. How many women do we have? 35%. That is the first statement that it will tell us. Then we are told that 18% of the digital camera customers extend warranty. So those that extend warranty is 18%. So 0.18, they extend warranty. Okay. Then what else are we told? That 10% of the digital camera customers are female, and under probability, I was just teaching that and means intersection. All right. So female and extend warranty. So these 2 here. Probability that it is a woman and the extend warrant is 10%, which is 0.10. Are we together so far on how I have summarized the data?
Yes, we are.
Okay.
Sorry, I'm quite behind on how you found the women for 0.35.
All right. How do we find the women for 0.35? Okay. So according to the store's history, we are told that 65% are male. So male is 65. So if these are male, the remainder should be female. So meaning the female should be what? 0.35 or 35, because these 2 must add up to 1. Is that clear?
Yes, yes.
All right. Any other questions before I proceed? Okay. So if that is clear, I will now proceed. So I want to simplify this jargon here. because this question is also there in your, it gets the questions from here, all right? So I want most of you who are in my class, we finish all these questions. That's why I've been giving you exercises. There are a few. So if I just type this to say, what can I type? Digital camera. Let's say Control F, digital camera. This is your Bible, digital camera. So you see this is a question coming from here. So your exam is coming from here specifically. So that's why I've been dominating on this particular document. So almost all these questions are here. Now I want to simplify, because even if you read this here, you'll not understand this jargon here. So I want to simplify it in the simplest possible way. So if you followed me with what I've explained so far here, let me proceed. So let me just rewrite what I've done. I was saying the probability of a male, 65%. So meaning the probability of a female or a woman is what? Probability of a woman is what? The one who asks a question, please.
0.35.
0.35, good. Then also we proceed to say that the extent warrant is what? 0.18. Okay. That we established. Then also we are told that the probability, we're given another probability. So 18% was at the extent warrant. Then 10% was at what? A female, and did what? And extent warrant, 10%. So a woman and extent warrant is 10%. So you're agreeing with me, this data is what we found in. So a woman, intersection what? Extended warrant is what? 10%. 0.10. So we're together with this data, we agree. Now what is the question asking us? The question is asking us, determine the probability that a male camera will extend warrant. So what are they asking us, these guys? They're asking us to calculate probability that a male extend, given that it is a male. So Bayes' theorem, those of you who are in my class, which data goes down?
Probability of M.
And then on top, probability of what? Extend, intersection what?
E intersection Y. W, sorry. M.
E intersection M, correct. Now, we don't have E intersection M, but we have what? W intersection E. So you need to understand that the probability that a woman end extends. So the probability that a man end extend should be equal to the probability that I'm saying the probability that a man, using theorem 2, probability that a man extends plus the probability that a woman will extend should be equal to 1. This is theorem 1. Okay, the common letter here is what? Letter E. So the probability that a man and extends plus the probability of a woman and extends should be equal to, that's the probability of having an extension. So what is the probability of a man extends? We don't know. It's what we want here. We don't know. But probability is a woman and the extent we know is 10%. But the probability of just an extension we have is 18%. So to bring this one here, so man and extends of what? 0.18 minus what? 0.10. So the total will be 0.08. So this is the answer that will come here, 0.08 divided by the probability that it is what? A male, 0.65. So when you divide that, 0.08 over 0.65, we get 0.123. This is our probability that a male, the probability of an extension given that it is a male. So 0.123. Does it tally with what is actually in the question, the original question? Let's check. Probability that a man will do an extension. So, right, choose the extension given male. They're using different denotation, but it's the same. So 0.123. That is what we have found here. So if you also got this, or whoever helped you with this, that is the answer for part A. All right. I'll teach this. I'll be in Lusaka, I think, over the weekend. I'll need to teach this. Such questions will repeat because assignment questions, they come into your exam. So when your tests make up your exam. All right. So I can proceed to the second part of the question. Are female customers more likely to purchase the extended warrant? Then justify your answer. So if you want to determine whether female are more likely, we need to understand this. Okay, so a female more or less likely to purchase the extended warrant, justify your answer. So we firstly need to find the probability that an extension will be given that it is a female. So extension given female, it's going to give us this answer there. Okay, 0.286. Then you're going to compare this 28.6% to the 12 point. In short, what answer here we're finding is the probability in my context. What this question is actually asking us to compare these answers here. Warrant given is coming from the female and the answer just from finding warrant coming from the male. Which one is higher? All right, so now they're asking you indirectly. Are females having a higher chance of extending than males? So you compare these answers here. So this is 28% coming from the females. And this is 12% coming from the male. Seen that? So who are more likely, males or females? Who are more likely to do the extension? So we can see from the comparison.
Females.
Yes. So females is considerably higher at 28.6% and males who are 12. So this is a justification. We're comparing the figures. Okay, I am done with that. So this is question number 2. These are assured what? 6 marks. So do your works, personalize them, and apply them differently. Okay, so I've done these works in 4 different samples. So those of you who have checked the solutions should also make sure that you understand there are small errors that will come in there. But I need you to understand what you're doing. So part B now, we go to a researcher at a major automobile company classified by car ownership has the following frequency. This was the easiest question here. Find the what? Expected value and the standard deviation. Expected value is simply found by multiplying the values of x times the probability. So we just multiply 0 times 0.10, 1 times 0.30, 2 times 0.40, 3 times 0. The total is what we call our mean or expected value, which is 1.8. Then when you square the values of x, you square them. 0 squared is 0, 1 squared is that, squared is that, b squared is that. Then you multiply by the probabilities. The total, you subtract the 1.8 squared. So you're going to get 4.44 minus 1.8 squared. We get 1.2. This is called the variance. When you square root it, we get the standard deviation. So this is the figure here, 1.09. So this is a sure value. So we have passed there. I think I discussed this in class as well. I expect this question in your exam. Those of you who don't have my number, please master my number by heart. Among the formulas in QM, this should be formula number 1 to master. All right. Are we following? Are we enjoying the transition of the slides? Or am I a little bit too fast?
I haven't gotten the numbers up.
Tisha, do you have the statement?
You're the only one who doesn't have it.
Oh, this blue one here.
All right, you've copied it.
Yes, thank you.
So now move to Aliyah, are we on the same page?
Collins, I'm a little bit lost on probability, but we move on.
No, I can't move on until you understand.
No, the other one, not this one. That one is okay.
Which one?
This one, the warranty, male, female. Yeah, this one.
This one I'll teach it again, but just know that it's
Okay, all right.
Okay.
Okay, we'll go through it over the weekend. That one.
All right. Okay. Great.
Collins, I can't hear you.
Okay, I'm saying this is the last question right now, so I'll just quickly rush through it. Then I think we'll end on it. So we'll end on this last one. I'm sure people are supposed to be in their offices. So can I quickly rush on question number, the last part? Okay, so use this typed copy I have here. So whenever we're asked to find the mean is simply n times p. So our p, according to the question, 10%. So if your 10% is your p, meaning your q should be the remainder to get 100%. So 90% is your Q. Is that are we together? If our P here was 40%, here there will be 60. 30%, 70. The relationship between P and Q is that the two must add up to what? 100. So our P here is 10%, 0.10. Our N, the number of what? As good as 1,000. So 1,000 times 10%, which is 100. So this is binomial normal distribution. Then to find the variance, we find NPQ. We already identified that our N is 1,000, our P is 10%, our Q is what? 90%. So this is 90, 10%, and 1,000. You multiply them together, they become your variance. You square root them, they become your standard deviation. So that is that. Good. That is your 2 marks for those two. 1 mark here and another 1 mark there. Any questions at this point? Any questions so far? If that is clear, I will go to what is called the kurtosis. So the kurtosis of the distribution is given by 1 minus 6 PQ over NPQ. All right. So our kurtosis is 1 minus 6 PQ over NPQ. So our NPQ, just squaring this number, our NPQ was 90, which is our variance. So 90 there, then 1 minus 6 PQ. So our P is 10%, our Q is 90%, multiply by 6, subtract from 1, you get 0.051. So this is the answer. I repeat, there's a kurtosis, which is in this case called the moment coefficient of skewness. So our mean, we said it is simply NP. Our variance is simply NPQ. So our variance was found as 90. Our mean was found as what? 100. Our standard deviation was simply found as square root of 90, which is 9.49. So the moment of skewness is simply, firstly start by subtracting your Q minus P over our standard deviation. So our Q was what? Our Q was 0.9, our P was 0.1. And square root of that, we found 0.084. Then the kurtosis is 1 minus 6 PQ over NPQ. So our PQ, 90% times 10% over our variance. The variance here, I've already explained, is the 90. So that's where the 90 is coming from. Is that clear? Any questions so far?
No.
I have a question there. What are we trying to get? Is it kurtosis or something? What is the explanation of that concept?
Okay, so there's what we call skewness. Skewness looks at how bending your distribution is. If it's bending to the right, we say it is skewed to the right. If it's bending to the left, we say it is skewed to the left. This is what we call skewness, but kurtosis is the height of the distribution. So kurtosis looks at the height of how our distribution is, the peak. Now this peak is calculated using its own standard formulas. These are theories of determinability. So to start with, I was saying that if you're given For instance, n is 1000, and you're given your percentage as 10%. Decimal, this is the same as what? 0.10. You can use this to find your Q. Your Q is simply 1 minus P. So 10% from 100 is 90%, which is 0.9. This one is okay, eh? How to find the Q altogether? If P is 10%, Q is 90%. If it would come altogether?
Yes, we have to. Yes.
All right, okay. So after finding that, there's what we call the mean. The mean is simply NP. Just multiply your N, which is 1000, times the probability or proportion, 10%, to get 100. So this is called your mean or expected value. Then we have what we call the variance, simply NPQ. So NPQ, we have 1000 there. We have P, which is 10%, 0.10. We have 90%, which is a Q. When you apply all these things together, you're going to get 90. This is called your variance. Standard deviation is always the square root of variance. So when square root the variance, this is where we get the 9.49. But if that with anyone behind, please speak now or forever hold your peace. Okay. Then there's what is called the moment coefficient of skewness. Moment coefficient of skewness. Moment coefficient of skewness. So a moment coefficient of skewness is found as follows. The moment coefficient of skewness. The moment coefficient of skewness is simply found as follows. Simply Q minus P over the square root of the variance. So our Q was 90%, our P was 10%, our variance was what? 90. So when you calculate that, you get 0.084. That is what we call the moment coefficient of skewness. And we also have what we call the kurtosis. Kurtosis is simply found by, kurtosis I've explained is the height. So kurtosis is simply found by 1 minus 6 PQ over NPQ. So 1 minus 6, so 0.10 and 0.9, then divided by 90. So the NPQ is 90. The final answer there will come out to be 0.0051. So these are the answers that you're supposed to have. And the whole assignment is done. So we're able to do this assignment in 30 minutes. I will also explain on Sunday. I will end here unless there are any questions to ask here.